You're listening to Coding Blocks, episode 29. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
Visit us at codingblocks.net where you can find show notes, examples, discussion, and more.
And send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks. Head over to Facebook at facebook.com/codingblocks or head to www.codingblocks.net and find all our social links there at the top of the page. And with that, welcome to Coding Blocks. I'm Alan Underwood.
I'm Joe Zach.
And I'm Michael Outlaw.
And let's go ahead and get started with some news. First, we have some new reviews and...
Big shout out to Sean Lee, Mike, and Dead Iron. Thank you guys very much, and thanks for mentioning the bidet. I've been trying to forget about that.
and Mike, that was well done, holding us at ransom for the review. That was a good job.
Well, now don't give everyone else an idea. What are you doing? Don't spread that.
And Sean Lee also, I think that was from Stitcher, right?
Yes.
They were saying that they were very selective about the podcasts they listened to, and they really enjoyed the algorithm one we did. So thank you very much for the kind review and for putting us into your highly selective list of listening material.
Yeah,
that's
very
awesome.
nice. Awesome. We've said it before and we'll say it again. Thank you guys for taking the time to write those reviews. We really do appreciate it.
Yep.
So let's get into this. I thought this would be interesting. So we've done a couple surveys over the past couple episodes. And let's start with, I'm going to quiz you two guys. Regarding the first one we did, it was regarding the frequency of the podcast. Which would you prefer most? And we had a couple options in there. 1 hour to hour and a half versus fewer episodes or shorter episodes that were released more often in like 10 to 15 minute length segments, or a show that was around once a week but 30 minutes in length. Which one of those do you think fared well?
What about you, Joe?
Just gut feel.
Yeah, I'm going to guess once a week, hour long, like This American Life.
Okay.
Yeah,
that wasn't one of the three that I said, but okay.
But yeah, I'm thinking the once a week was probably pretty high up there, and then only because I had seen the original one, I was surprised as many people like the format that we had right now, which was longer every few weeks.
So once I tabulated everything down and like took some of the free form ones and broke them down into like one of these categories, right? To just have a smaller set of items to talk about. It broke down into the current format being tied with shows released once a week at 30 minutes in length.
Interesting.
So the 1 hour, you both mentioned once a week at an hour.
Well, I said once a week. I didn't specify the hour.
Okay. Well, that one was a fairly popular write-in. I guess it was an oversight on our part that we didn't put that in as one of the default choices, but it was a popular write-in. However, it was as popular, the same amount of popular, as the shorter episodes that were 10 to 15 minutes in length.
Interesting.
So I thought that was an interesting take that, our audience were mostly consistent. They mostly fell into two very popular camps. And then the ones that didn't fall into those two popular camps fell into like two other consistent camps
that they chose.
It was an even divide among those.
So I guess now we need to figure out what our takeaway from that is, whether we're going to start trying to do some more frequent episodes or whatnot. I mean,
it sounds like that there's not, sorry, Joe, but it sounds like, people aren't going to be upset if there was some more, right? But a lot of people did like the current format too, so
a lot of people
we'll have to try to figure something out. Yeah.
These are tied at 43%. So it's a big drop off to number 3.
Yeah. It was, the first two were tied at 43%. Sorry, I didn't get into that, and then the other two options, one of those was just a popular write-in. Those were roughly 6.5%. So it was a big drop. So let's get into the second poll or survey, which was years of programming experience. You guys have any guesses as to which one you think? There were 5 options: less than 1 year, 1 to 2 years, 2 to 5 years, 6 to 10 years, or 11 plus years of programming experience. And if you're listening along, you can play along with us and say your vote out loud while these two guys ponder.
I honestly think that probably 1 to 2 years was the most popular. And to be fair,
Okay.
I did not look at these results at all.
Thank you
so
for
I
not.
I have no idea.
Thank you for not cheating like Joe did.
But I'll tell you why, because most of the people who write into us are the ones that and I think it might be those people who are more curious because they haven't been in the field yet, but that's why.
So you're saying 1 to 2.
1
right?
to 2
Okay.
would have been the majority.
Joe, what do you think is the most popular?
I could have flipped the coin. I really couldn't have predicted anyway, but I was surprised to see what the answer was.
Okay.
He
well,
cheated.
yeah, he totally cheated.
Yep.
Yeah, the majority of our audience is 11 plus years.
Really?
Yeah, the second most popular, bucket was the 2 to 5 year mark. So it was 33% for 11 plus years and 24% for the 2 to 5 years. The 1 to 2 year range that you thought would be most popular was the absolute lowest.
You know what's awesome?
It was actually tied for the lowest. It was tied at it was 13%, and it was tied with less than 1 year.
You know what's awesome about that to me? Like, it actually excites me because that means that there's a few things going on. One, people are generally they are genuinely looking to better their programming experience, even though they have 11 plus years of experience, right? Like, that's amazing. And the other thing that I find really awesome about that is that, you people who are listening right now, you're actually finding what we're doing valuable enough to even, to listen, and with that much experience, go up there and take our polls. So I that's flattering and awesome all at once.
Yeah, in that poll obviously hasn't been available as long as the one regarding the frequency of the show. So it'd be interesting to come back and see, over time how
As
that
time
one
goes on.
But
Yeah, awesome. Thank you
was
very
interesting.
much for going and filling in those surveys, guys. That's excellent. I say guys, gals as well. So everyone, thank you. So next up on the list, so right before we started recording tonight, we got an email from Lou, and he's kind of got an interesting situation because he's later in his career and he's getting ready to go back to school from scratch and essentially go through a 4-year school to get into programming. And he's kind of wondering, what is this? Is this a bad thing? Is this something that we've seen? I mean, do people actually come out as junior level programmers later in their career? And here's my take on it. And both these guys will also fill in on this, but I don't think there's ever a time to that's too late to get into something. If you have a passion for it and you truly have a drive to do it, the only thing that I think would really ever hold any back is if you financially can't afford to take that step back, right? Like if you are a master, I don't
it
know.
sounds like he's fortunate enough that he can.
Yeah,
take
if
that.
you
So that's,
can do it, and
good for him.
My take on it is this: there is never too many people that do a fantastic job at anything. So if you come out of this thing and you become an excellent programmer, you hone your skills, you're thorough, you think through problems well, you do all that, there's room for you. And it doesn't matter what your age is. If you're somebody who's easy to get along with, you communicate well, and you become skilled at your craft, absolutely, man. And I will say, you mentioned not getting into the field until, closer to when you graduate. My recommendation would be try and start getting work a little bit earlier on, even if it's a junior level type thing, or go to one of those sites we mentioned previously, like topcoder.com or Project Euler or some of those things. Yeah, Euler. So do some of those things because you would be shocked at how much better you'll get and how much faster it'll happen if you get involved in doing that kind of stuff. And then you can put those kind of things on your resume, or even putting code into like a GitHub project. So yeah, I'll let these guys carry on with this, but that's my 2 cents on it.
Yeah, I mean, so as a 21-year-old, I will say that my take on it is that it's definitely, I feel like there's never a wrong time if you feel like you need to reinvent your life. I don't feel like there's ever a wrong time to do that, right? Just if you feel like you need to do it, if it's something that you want to do, if it's something you're passionate about, go for it. What frustrates me though, and the problem is that there have been people that have put data together to back it up. And I'm not saying like I've bothered to investigate how accurate the data is or whatever, but like here's an example that I quickly Googled that bothers me. And it's a quote. It's maybe a well-known quote from Mark Zuckerberg. And he says, "I want to stress the importance of being young and technical. Young people are just smarter." Why are most chess masters under 30? I don't know. Young people just have simpler lives. We may not own a car. We may not have family. Simplicity in life allows you to focus on what's important. And I kind of understand what he's getting at, but it's frustrating to say that, like, well, if you're not in your 20s, then you can't solve technical problems.
Yeah, and that's not so much an issue of getting a late start as it is just not being that age anymore. And it kind of implies that people are going to age out of the peak of their career early.
Well, and that's kind of like what, going back to Lou's email, though. I mean, he was talking about like companies going after, being willing to hire someone, in their upper 30s to, early 40s was the age range that he had questioned. And that's why it bothers me. Like when you see here's, the head of a major .com company, right, making a statement like that, and you're just like, wow.
What's he say behind closed doors?
Exactly. I'm sure the official, HR legal answer is that no, we'll take anyone. But
right.
He's kind of vocally saying, being quite public about it.
I will say, if you take it a step further than that, I have seen and heard of companies like when you start getting closer to retirement age, when you're in your 50s. Then it becomes a question, right? Like, do we want to bring on this guy that we know that, in 3 years, he's basically going to be leaving? That's always a question. I think the age range that he's talking about right here that he'd be in, that's not usually the question. But there are companies like the Facebooks of the world that think that, hey, the younger generation is where it's at. Probably for several reasons. One, they're cheaper. Two, they don't have all the other things. They don't have families that are in the way, so they can work 16-hour days, and they think it's cool that there's a PlayStation 4 in the break room, right?
I've definitely been in those environments where they're like, oh my God, they let us spend the night here, and
right,
we got Xbox.
Yeah, and so I mean, it's a different. There are definitely places you're going to walk into that all have different vibes, but again, I will go back to like. There is always a place for somebody who is good at what they do and fits on a team well, because there are plenty of people out there who are not good at what they do and don't meld into a team properly.
And I agree, and that's why I worded it the way I did, was that if it's something you're passionate about and you want to reinvent your life, go for it.
Yeah.
Don't just do something half-heartedly because you think like that it might be better. It should be something that you're truly interested in, so that you'll have that drive to want to continue bettering. I mean, I look at it this way: I've been doing this career for quite a while, and I still study new topics all the time. Right, so just because I'm not submitting homework doesn't mean I'm not still studying. Right, it has to be something you're passionate about.
Yep, and also want to stress the importance of networking, especially with a resume that's going to look a little different than the people you're competing with. It's really important to go out there and shake hands and get to know people at meetups, and also being able to show something, some sort of side project or some sort of something on GitHub or somewhere else, just to kind of show that you do have a passion for this and that you're for real.
That's a really good point. I mean, even someplace like Stack Overflow, right, where you get cred for answering questions or that kind of stuff. Yeah, that can never be stressed enough, is the importance of networking. It really is underutilized by a lot of people, especially in the tech industry. So, yeah, excellent email, excellent question. Hopefully we've given you something to walk away with positively on that. And the next thing I wanted to do is, in going into the whole education thing, it's been a few years, because I am also 21, since I took the course on algorithms back in college. And I don't know if you guys know about this, but there's sites out there to where you can actually take university level courses for free. And one of the sites out there is called Coursera. And there is an Algorithms Part 1 course that I'm just going to take that starts in July, I think in just a few days. So we're going to leave a link in the show notes, and anybody else who wants to join me and maybe, see how well they do in algorithms, it's going to go over things like big O notation.
What's also important to note, though, that for those that aren't familiar with Coursera, this is a Stanford University class.
It's major, and you also get it's not like you get college credit for taking it, but you actually get a certificate of completion and that kind of stuff. Like it's real. You have to do assignments. They get graded. You'll have quizzes. You basically watch videos throughout the week. And I think they said that it's about 6 hours a week of coursework, and it lasts 6 weeks. So anybody else who wants to polish up on their algorithm skills, come join me on this. And like I said, we'll leave the link in the show notes. And one cool thing about it too is any of you guys who are interested in interviewing at the Microsofts, the Googles, the Amazons of the world, something like this is fairly much crucial. So, that's it.
Yeah, great. All right. Also, I wanted to mention that I got the notes out of order a little bit here, but Independ 6 is out. We actually just heard. I think they fixed a couple of your gripes, Alan.
They did, which is awesome. So the two, actually, one of them that both Outlaw and myself shared was theming. So Independ 5, it was 5, right?
Yeah.
Independ 5 did not honor your theme. You could change it to dark, you could change it to whatever you wanted. It didn't care. It was just going to stay with its white theme. And then the other thing was the whole double clicking on the column dividers in a grid. It would just collapse everything down to nothing. They fixed that as well. So these guys listen. I mean, can you say that about a lot of companies out there writing software that you use day to day?
No, this is cool. It's a coder tool written by a coder, so he eats his own dog food, and that's really cool.
Yeah. That's most excellent. So if you guys haven't checked it out and you need a static analysis tool to tell you how good or bad your code may be and areas to improve upon, definitely check out Independ.
And if you're curious to hear our previous review and conversation about this product, you can go back to episode 15. It was titled "Independs on How Good Your Code Is."
Yep.
Very nice. Okay, so I think that brings us to the topic. So this week we're talking about other solutions for storing hierarchical data. In episode 28, we mentioned two adjacency lists and listed sets. So we're going to be probably comparing back to those a little bit. So feel free to go back an episode if you want to catch up on that. And this time we're talking about two new strategies for solving the same problem or similar problems, path enumeration and closure tables.
Yep. So let's go ahead and get rolling on this one. Path enumeration is also referred to as materialized path. I've seen that written in a few places. So this goes both for the same. And this one's actually fairly simple. If you think about like a breadcrumb, that's essentially what this is. So if you have a hierarchy of items, which again, continuing on the hierarchical path here, then essentially the way the data is stored is it will be your root node slash the subnode slash the subnode slash the subnode. And it doesn't even have to be slashes. It could be periods. I've seen them pipe delimited. The delimiter is not important. It's just the fact that it's basically stored in a string.
Parent slash child slash grandchild slash etc.
Great grandchild, yeah. And so the concept's super easy. I mean, you guys have probably seen this stuff written out. I mean, it's very similar to what you see in your Windows Explorer, right? If you go to your drive, you see C:, and then a folder, and then another folder. It's just, it sub all the way down. So, I mean, other than
in all of our, when we were prepping for the show, like that analogy that you just came up with Windows Explorer never once came up, and it is the most beautiful way to visualize what materialized path or path enumeration is.
It is exactly what it is.
C:/ program files / Microsoft Visual Studio 12 / common / IDE /
Okay, so
I've gone there a few times.
So if we imagine like a database of all our, representing our file system basically, then I would have a record for, say, my host file, and associated with that, I would have a field that contains the full path to that item. And that's really nice because I can say things like select star from files where path like C program files,
Yep.
right?
Yep. And then also you could even take it a step further. Now here's where it kind of sucks though, because indexes don't play nicely with this. But you could actually say where like hosts, right? And then it would go get you all the paths that have a host file as the very last string in there. So you could do that. Again, SQL indexes usually aren't smart enough to be able to reverse up like that. You'd actually need a full text index or something to make that fully efficient. But yeah, I mean, it's really easy to query. It's
Well, but see, here's the thing, and I was really hoping that maybe one of you two guys would have like to be able to talk me into it, because I've never been a fan of this. Anytime I've seen it in a table for any reason, where it was trying to, the purpose was to just flatten out the hierarchy, and I've never been a fan of it. You say
don't
that it's
like
easy
it.
to query, and I would agree that it would be easy to write the query, but from an optimization or from a performance point of view, like you're taxing the server because it's doing a bunch of string manipulation to do that search. So while the query might be easy to write, the work that the server's doing isn't as easy as other hierarchical data models that we've talked about.
Yep.
And
Yeah, it's not normalized at all.
And there's no integrity. There's no referential integrity checks. There's no. It's a string.
So my question to you guys then is like, talk me into why I would want to use path enumeration.
I won't.
Yeah. Yeah. I mean, it is convenient. I've done. dirty things
that's
too.
fair. That I asked for it.
Yeah, there's been times I've done this before. I consider it an anti-pattern in databases, but there's been times when I've, popped a common delimited list into a field for convenience, and sometimes that's all you need to do. And it's not great. It's not scalable. It's a lot of extra data, and it's not great for, there's no integrity. Indexes are kind of yucky, but it's quick and dirty.
Well, and I'll give you another thing that if you take it a step further, when you just start talking about database architecture and how it works behind the scenes, if this list gets big, now you're going to have your data splitting across page files. Like your performance can really start taking a major hit.
Oh, what if you decided to change the middle of that structure?
Yeah,
you lop off one of those tree nodes, and now you have to go back and rewrite all those strings.
So here's why I will not ever talk anybody into doing this one. If you look at it from the perspective of maybe a product catalog in an e-commerce situation, let's say that you have 10,000 products that all existed under some subcategory. And all of a sudden, you're going to get rid of that subcategory and you're going to put it under another one. Typically, the way these things are maintained are through triggers. So if you change what category it belongs to, it's going to go back through and automatically update all those fields.
Horrible.
It is horrible because now you made that one change where you just moved all those products from
This
one
was
point
you trying to talk me into
No,
it?
no, no. I'm telling you why I would never.
Oh.
So if you moved all these 10,000 into something else, it's now going to update all 10,000 of those products, and it's going to have to re-query to find out the entire structure for each one of those to then update it. And the problem is, okay, that sounds bad enough, but when you start introducing that into something like a transactional system, you start locking those tables, and so everybody else is trying to access that data is now shut out.
So I don't know. Did we give like an actual concrete example? But I don't know if we did or didn't. But let's just say for simplicity, you have 3 records. Okay, a record 1, ID record 1, ID record 2, and 3, and 1 is the parent. 2 is a child of 1, and 3 is a child of 2. So your path enumeration might look like 1/2/3 on record 3.
On record 3. And record 2 would be 1/2.
Yeah, and record 1 would just be 1.
1, correct.
Right? So there's this column that could be on the same table as those records, or it might be in some other column, or some other table. But the point is that all of that data would be in the one column. So kind of like how we talked about adjacency list, where every record knew its immediate parent.
Yep.
In a path enumeration, every record knows its entire lineage. That is the one and only pro that I can come up with.
Oh, there's actually a really good one. A huge advantage over nested sets and adjacency lists is you can actually have multiple lineages. So if you break this item out from its lineage, you can actually have a breakout table and have multiple lineages. So
yeah.
In a file system example,
Okay,
like we talked about,
fair
you could
enough.
have linked files or soft links. In e-commerce example, if you had like a gaming mice, you could have that under electronics, computers, accessories, mice, and you could also have it under toys and games.
Okay. So
Yep, that's cool.
there's
Yeah, it's not
another
a tree.
example. So, all right. So fine, multiple parents and every child knows its entire lineage.
But what absolutely sucks about it is, let's say that you do have this lineage and it's 5 deep, right? And you want to know, instead of just the ID of the middle category, you want to know the name of that category. You don't have to parse that string.
Oh,
You-
right.
You have to split that string on whatever the delimiter is and say, okay, now I have to assume that's an ID. And I say assume because there's no referential integrity there.
Right.
And now you're going to have to say, okay, that was supposed to be a number. Let me try and join over to this category table to get it and hope that nothing blows up,
See,
right?
here's in my mind and this is true for any type of code that you're ever going to run into in your life. In my mind, if you're doing any kind of serious string manipulation in order to do something, like you have to manipulate some string and start, you're running a regular expression against it to start getting out tokens so that you can decide what you need to do or, what actions to take. Like that's a serious code smell. Something's wrong. And this is what path enumeration feels like to me, is that just like you said, you got to have some regular expression to break that apart into its separate tokens so that you can get what's the third ancestor above this particular record, right? It feels wrong.
Yeah, and it is. I would never, ever, ever recommend doing this. So
when would you? But that's the point, is that there must be some value to it, or else it wouldn't be a thing, right?
Well,
no one would do
I'll
it.
give
It
you
wouldn't
a few.
exist unless somebody found value in, here's a particular use case where path enumeration will just rock your world.
I'll give you a few. If you don't have a database system that supports something like a CTE or any kind of hierarchical data set type stuff, MySQL is an example. You can basically... You can get away with doing this because let's think about it in SQL Server in the olden days before you did have CTEs. The olden days back in 7. The way that you would do this kind of thing is a lot of times this is what you'd see because there was no built-in way to do it, and the only way to do what you needed to do was to write some sort of stored proc that would loop over things with a cursor usually, and then insert into some temporary table to get your hierarchy,
So
which is
Joe,
slow.
I think what he's telling us, and you tell me if this is what you took away from that, Joe, is that this is an outdated way to do it.
Yeah, if only there was a way to solve this problem and store these associations, but maintain referential integrity.
Woohoo! Dun,
All
dun,
right.
dun.
So is that your way of telling me that we should segue off of this? And
I think that was a Sagu.
yeah, I think so too. Well, before we jump into that, though, let me take one quick moment to say that you've probably heard me ask for this before, but if you haven't already, we greatly appreciate it if you would take the time to go to Stitcher or iTunes, wherever you prefer to find your podcast, and drop us a review. It helps others to find us, and we greatly appreciate that. And when you take the time to do that, we actually see the results of it, and we really appreciate it. And it really makes us feel good when we read some of these results.
Yeah, it's huge. So please do. And to make it easier on you, you can go to www.codingblocks.net/review and then pick your poison, iTunes, Stitcher, whatever. So please do that. Also, I do want we don't touch on this very much, but so our show notes, like we take pride and put a lot of blood, sweat, and tears into doing the show notes on this. And we try to make it in a way that whether you're using an iPhone or an Android device or a tablet of some sort, most of those, like I know you guys use the podcast app on iOS.
Yeah, the built-in iOS podcast app.
I use Pocket Cast on Android, and if you go to the show notes on any one of the episodes, we've got it set up to where like you can click the links easy to go look at whatever we're talking about.
Yeah, you can read the full-on show notes straight from the podcast that you download.
Yeah, you don't even have to go up to the website. We're not trying to tell you to stay away from the website, but we want to make it easy on you. So
we want you to have the information.
yeah, so you can go there. And if these polls and these surveys that we mentioned, you can actually, we'll have the links there in the actual show notes as well. So if you want to be able to participate, but you forget or whatever, while you're driving, just go I'm kidding.
Not while you're driving.
You could go to the show notes and literally we'll have the links there and everything else. So if you weren't aware that you can see those directly in your pod listener, you probably can just explore a little bit.
And for those that do like to hit up the site, or if you haven't already, be sure to hit up some feedback on each episode too. You can go down there and leave your comments directly to a particular show.
Yep. So,
All right. So to kind of bring us back to the topic, we were just talking about what was it called? Path enumeration.
Crap
And
enumeration.
it's
Oh,
basically-
yeah, path. Sorry.
Yeah, we're not a fan of this one, but you basically associate the breadcrumbs with your record or node, and it's easy for querying, but it's gross to maintain, and
No,
it
it's
just
not easy
feels
for query.
dirty.
It's easy to write the query.
It's easy to write the query. I like that.
There's a
Yes.
difference.
there is. Okay. All right, so that moves into if only there was a better way. And there is. Coincidentally enough, that works with any database system out there. I don't care what it supports. We're talking to you, MySQL. The closure table method.
Wait, is this a JavaScript thing?
It could be. So
But
here, let's see if I can somewhat put this into. I want to go 3 levels deep, like what Michael said a little while ago, just to keep things simple starting off. Level 1 is the top, level 2 is a child of level 1, and level 3 is a child of level 2. All right. The way a closure table works is this. It is a separate table. It's off by itself. And I'm going to, in the same vein that Michael told me on the nested set, I'm going to go ahead and throw in this additional information on this one as well, though. In a closure table, you have an ancestor column, a descendant column, and then you don't have to, but you add in a depth or a level column. And that's easy for querying. But essentially what you've got now is this. This table is going to be every single combination of every record and its associated descendants or ancestors that exist, period. So, first off, let's do the big O because we actually had somebody ask about big O notation on the nested set model. And we went looking for it. I think Outlaw's probably going to go.
on.
He's going to go look for it while I talk through this.
I forgot to even mention that at the start of the show.
So here's the one downside to a closure table is given big O notation, it could actually be O n squared. All right. That is absolute worst case scenario, which almost never happens because that means everything would always be at the very bottom level. But here's how it works.
But that's a pretty bad one, though.
It would be bad, but it doesn't ever
scales
happen
terribly.
that way.
O of n squared.
Is bad, but it won't typically ever happen that way. It's usually quite a bit
Okay.
less than that. So
So just to make sure I understand it, we're talking about basically storing the association between my node and everything in the hierarchy. So if we're looking at the 1, 2, 3 example, that means I've got a row in there for 1, 3, a row in there for 1, 2, and a row in there for 2, 3.
well, let's take it all from the top because you missed a few. So you're going to have 1, 1 to itself
Okay.
with a level of 0, then 1, 2 level of 1 because that's its child, then 1, 3 level of 2 because it's its grandchild. But then you're also going to go down to the next.
So
one.
hold on.
Yep.
Because so far we've only described the
For one.
hierarchy for one part of the node, and he's already added 3 records.
where the ancestor is 1, right? So all these were ancestor 1. All right. Now, if you wanted, so now you've also got to do this for ancestor 2 and 3. So now you're also going to have a record for 2, 2 level of 0, because it's itself, to 3, level of 1, because that's its child. All right. So now, wait, we had 3 records.
Now we're at 5.
Now we're at 5 records. Now for that bottom record, number 3, you've also got 3, 3, level 0. So now you've got 6 records for that one child all the way at the bottom. Now, it sounds bad, right? It does sound a little bit bad, but here's the deal. The reason ON squared, if you assume that everything was always at the bottom, that's why you get N squared, because basically it would have to do it for everything up the chain. You're not always going to have everything down at the bottom level, so that's not going to be it. It's definitely going to run into a decent number of records, but let's talk about why it actually is cool this way. First off, you're storing typically, if you're doing GUIDs, you probably just go shoot your server right now. But typically you're storing integers, right, for referential lookups. So querying these things is uber fast, incredibly fast. Inserting's actually pretty easy. And assuming that you don't have a crazy number of or a hierarchy that's 100 levels deep, then the inserts are also going to be pretty quick as well.
That's the problem, it seems like, with the closure table, though, is that it really is, if you have a crazy tall tree,
Yes.
then this is going to break down in a performance point of view.
No, it probably won't break down except for writes. Your reads are going to be still just incredibly fast, but your writes could run into an issue. But again, keep in mind, this table is not unlike the adjacency list or some of these other methods we've talked about. This is usually a standalone table that is literally ancestor, descendant, level. It's 3 columns. So, and these columns are typically integers, not always. If you have some sort of key that's not a surrogate key, then it might be something like a GUID, or it could be a string or something. But let's say for simplicity's sake that all your records were using integer indexes, right? So basically you have 3 columns and they're all numbers. So searching this, even if this was an incredibly tall table, is going to be stupid fast, because you can index it. You can index it based off ancestor, off descendant, and then you could also tack level on to each one of those, and now you can query this thing 20 which ways from Sunday, and it's going to be just fast.
So just to put this into different words, right? If in case if it's not already clear, so what this is doing is it's storing every path from each node to each of its descendants.
Correct.
Right? So there's a couple of things that I really like about the closure table. Number one, like you mentioned, simple integers, assuming you're using integers for your ID columns, that you can easily index. I like the fact that you can get the referential integrity there.
Yep.
That's awesome, right? I like that, like the nested set model, you can easily get an entire tree.
Yep.
Right? Where this one has an advantage over the nested set model, though, is that you can, without having to do any kind of crazy math, you can just easily get here's the hierarchy.
Yep.
Right? Where you basically had 3 columns: an ancestor column, a descendant column, and a depth column.
Yep.
So whatever your whatever node that you want the tree down from, you can just easily query, say, select star from whatever your closure table name is, where ancestor ID equals the node that you're interested in.
Yep.
The node on the tree that you're interested in, and then you can get all of it from there.
Yep. It's real easy. And let's just to give some examples what Mike was just talking about. So one of the things that's kind of cool is, let's say that you want all the descendants of something. The query is select all from tree paths. Let's assume that we named our closure table tree paths. Select all from tree paths where ancestor equal n, whatever the number was. That gives you all its descendants, because you're saying, hey, give me everything where I am the ancestor, right? Super easy. And then if you wanted to order it, you basically say, hey, order by the level. Done. Now you actually have a nice little thing that says, all right, so here was my child, my grandchild, my great-grandchild, whatever. Super easy to do. Now let's take the inverse. Let's say, hey, we want all the ancestors of this particular thing. Select all from tree paths where descendant equal n. So where I am a child, give me everything. Because there's a relationship to every single record walking all the way up the tree down to whatever that item is, it's very easy. And then you could, again, just order by the level. In this case, you probably do level descending to get it going in that order up from you. So, again, super easy. Now, here's an interesting one, though. Let's say you're going to insert an entry. And so Joe and I were talking about this beforehand, and one of the things that you'll see a lot online are comment systems, right? Like a form or something, because when you have a commenting system, right? Like the first person who comments, he's comment number one. If somebody replies, well, that's a child of that first comment. And if somebody replies to him, then that's a child of that comment. So that's why a lot of times you'll see that. Well, one of the things that's interesting is, all right, so you insert that comment into your comment table, right? And let's say it's comment 10. Well, the way that you would insert this into your closure table now, because now it needs to be able to relate itself to every single comment that was up above it in the hierarchy, you'd say insert into tree paths, and then you'd say your ancestor, descendant, and level. Now, instead of just a values type insert, you're going to say select ancestor, and then whatever that new comment ID is, so 10, and then do level +1 from tree paths where descendant equal whatever the immediate parent to that comment was. And then that is literally going to insert the records for all the parent records all the way up. And then you'd also have to insert itself as well. So you'd say insert into tree paths 10, 10, 0, right? So it's pretty simple. Now, here's the thing. Like we said, if this is a really tall tree or a really deep hierarchy, that could be 100 records if you're 100 levels deep, right?
Oh, actually, it's much worse than that. I just pulled some numbers for fun.
Oh, yeah,
So-
it would be worse than that.
Yeah, it's much worse. And this is where that the n squared comes in. So basically, in our simple example of 1, 2, 3 with the depth of 3, there were 6 records. Now, if we had 10 records with that same depth structure, so, 10 is a child of 9, is a child of A, is a child of 7, then you end up with 220 records.
Woo!
100 records.
But that's not n squared yet.
Well, it's actually it's pretty close. So if you had 100 records, right? Now we're looking at 10,102.
Actually, wait, 10 would be worse than n squared.
Yeah.
Well, what did you say? What did you say it was?
It's
How many?
200 some
N
odd.
N is 10, and we end up with 220 records.
Yeah, that's worse.
Yeah. So and that's where
The depth.
yeah.
Yep,
So I was
so
going to ask you
1,000.
if we had to decide. Okay, so we talked about
Well, hold
Nessa's
up.
set model in the last
Hold up,
one.
hold up though. What did you say? What was that other one after 10?
10,000.
1,000. Guess.
Oh, good God.
He said, for 1,000. Oh, geez.
What that would be? I have no idea.
Do some math. I'm going to say 1 million.
500,000. It's it's n times n plus 1 divided by 2. It's just a basic summation. But yeah, we're looking at 500,500.
Easy for you to say.
Okay. So here's all right. So here's the part before we go too much further. All right. Does anybody have a tree that's 1,000 levels deep? Right.
Yeah.
If you do, we need to talk.
Yeah, that's 1,000 items with a depth of 1,000.
Well,
Yeah.
okay. Yeah. So before we start bashing on the closure table, though,
Right.
I did wanted to come back with one comment that you haven't said yet, and that is that closure tables allow for multiple parents.
Yes, much like the other one that we were talking about just a
Path
second ago.
enumeration,
The
right.
path enumeration. Yeah, you can do as many as you want. It can
So
have
now
20
let's bash
parents.
on closure table.
Yeah,
Okay.
because it could be actually much worse than this.
So in the last episode, we talked about adjacency list and Nessa's set models, right? And I think at least Alan and I are big fans of the Nessa set models. Joe's kind of indifferent. Is that fair to say? Right. So
Yep.
my question though would be, I'm going to make you pick now, Joe. So, because you didn't really care about adjacency list versus Nessa set model, but a closure table versus Nessa set model, I'm putting you on the spot.
Yeah, if it's a true hierarchy, I'm definitely going nested sets. It's easy to query, it's easier to maintain. But if I need, a true graph, if I need cycles, then I think that closure tables is my solution.
Wait, you said the nest set it's easier to maintain?
Well, I think he means it in terms of like the batch process that's going to do it.
easier is tough to define, but to me, it's just a lot less data and it's more human understandable. It's every time you make a change, it's not 100 inserts or updates.
No, so the nested set model.
Yeah,
is,
you can't do that with an SSL.
Yeah, they're both horrible.
Yeah. Thanks, Joe.
Let's just screw it. Let's just do path enumeration. It supports cycles. It's simple, and string parsing isn't that hard.
All right,
and that's probably why it's a thing.
That concludes this episode. Thanks all for listening.
Right. Right.
No. So
let me hear your take on it, Alan.
So
Same question to you.
Here's my thing. I do closure pretty much just about every time. The only thing that would drive me away from it is if I knew I was going to have a tree depth of greater than, I don't know, 50. If you got there, then it starts becoming a thing. Because here's the deal: if it's performance that you need, but it's transactional, I don't think there's even a question. You have to do the closure. If it's something that you can do in batch, like we talked about with the nest set, we've both done them before. They are super fast to query and actually very easy to write queries against unless you're doing inserts and updates and whatnot. My thing is space is really cheap nowadays, right? And SSDs are on the market and people are using them in servers. So,
well, let me clear up one thing, because when we were talking about the big O notation, we're talking like O of n squared rows for closure table. Right, that was the worst case in terms of the number of rows. So when we're talking about big O notation, we're not talking about in terms of complexity to create it or to query it. Right, so that comes back to a whole other conversation.
Right, good point.
So if we're talking about in terms of space, since that's what you're talking about, then nested set models is less,
way better.
It's going to be O of n.
Yeah,
it's going to be whatever.
It's 1-to-1, but
it got this many rows. You got this many rows,
but it does not support multiple hierarchies, and you can get cyclic. Issues.
No. You can have multiple hierarchies within a nested set table. What you can't have is multiple parents from a node.
Multiple parents. My bad.
So both closure tables and nested set models will support multiple hierarchies can coexist in that same table.
But the parents.
Closure table will allow multiple parents.
And here's one other good thing. So we talked about before, like if you're trying to batch process something like a nested set model, and there's some sort of something references a parent that it shouldn't have, you get into the circular dependency, it's going to crash everything out, right? You don't necessarily have that same issue over here. You build those records on the fly and then it's done. So querying it, I don't think you run into that same circular breakdown that you would with a nested set model. But here's my thing. Space is cheap. The nested set model, or not the nested set, the closure table is easier to insert records into, easier to delete from, easier to update, and super stupid easy to query. And it's a very small table, and you don't have to batch process it. Like, in my opinion, it wins. It pretty much across the board, except for space. If you're talking about space and space is at a premium, then this may not be your key. But in just about every other situation, it seems like it wins.
Okay, so I'm going to put you back on the spot again. Let's say you have 500,000 records.
Mm-hmm.
Okay,
that's a lot of records.
You were talking about a tree. If your tree was 1,000 deep, but what we're talking about here is like it doesn't necessarily have to be a deep tree,
right?
So you have 500,000, whether that's 500,000 products, or when we talked about nested set models, we talked about employee hierarchies. So it could be 500,000 employees. You have 500,000 records.
Mm-hmm.
Which one?
If there are multiple parents, then there's no question, right? Like you basically got to go that way. But let's say if it's 500,000, what are we saying the level is? 5 deep?
Unknown.
You got to have at least some sort of cap.
You're walking into it. You don't know. You have some process. You're either going to create a process that's going to look at some data and flatten it into a closure table, or it's going to flatten it into a nested set model.
So the first thing I would do is I'd find out how many levels deep it was. So, and then after that,
cheater.
After that, I would say, I would probably, and this is
go back to your little calculator that you had there, Joe. What's 500,000?
No, but that's levels deep. That's not fair. So, in all fairness, like truly, what I would do.
No. That was supposed to be based on the number of rows, not based on the depth.
Oh, come on! You said an employee. You're gonna have 500,000 people, and they all report to the person above them. Yeah, that's not gonna happen.
No. But what I'm saying is, wasn't the O of n squared? It wasn't n wasn't the depth, was it? It was the number of.
It's the number of rows, but it usually assumes that the deeper you go, the more rows it creates. But at any rate, so it honestly trying to solve that problem, what I would do is the first thing I would probably try to do the closure table, find out how many records it ends up with overall, given whatever depth, unknown depth and unknown number of reports at whatever level. I would do that. If it only hit a couple million rows, I'd probably stick with it.
500,000 squared is going to be 250 billion.
Yeah, that's not going to
Yeah,
happen. Right?
I have the number about it. I just don't know how to say it. So actually, I got it. Okay, 125 billion 000 zippity.
I feel like a Googleplex is going to come in.
But
Yeah,
no.
can I Google how to say this number?
But I mean, seriously, that's like one of those things to where you don't know what's going to fall out until you do it. So the way that I would approach it is I would probably attempt the closure table first, find out, hey, what's the damage, right? What's the amount of space this is taking up on disk? After I index it, how fast does it run? Because let's be real, right? Any database.
This is where I feel like the advantage to nested set models, assuming you don't have multiple parents, this is where the advantage to the nested set model comes in, because I don't have to know all that. I don't have to take the time to
it's
say like,
also been for rows.
let me figure out how many levels there are. Let me do a test run and see like how long did this thing run? How many rows did it create? How much space does that take up?
In fairness, that would be another thing that I would take into consideration as well is, hey, is this something that doesn't change? Is it not transactional? If it's not transactional, maybe then that's what is the way to go, because it's going to be faster. Who cares if it takes 2 minutes for it to create all the records? However, with the closure table, if it is transactional, that's going to be the first thing I look at, because
That's true.
I can't wait.
There
on
are
something.
some other additional requirements, but
Right.
I wasn't specifying that.
Right. So
Cheater.
I mean, I like the idea of being able to using straightforward SQL to create, update, delete, and query these things on the fly, right? That's the beauty of the closure table. Whereas with the nested set, it's not. You basically do have to create some sort of process to update these things. Now, that being said, there is something really nice to be said for, hey, you have a one-to-one relationship with every single record, right? That's excellent, fast, and easy to actually just look at and kind of see what's going on.
Yeah.
I mean, what about you, Joe? Did you give up on all of it? Are you doing a document database structure now?
Yeah, I'm actually looking at other strategies for solving hierarchical data.
I mean, there's and that this particular
Is
show
it called Solar?
we haven't. Well, I mean, there you go.
Search engine, duh.
That's actually one thing, but we weren't even going to talk about it on this particular show. But there's always something like a document database, right? To where you can literally store whatever you want as subnodes of something, and then you don't even have to worry about any of it.
We should talk about search engines. That'd be a good show, I think.
Yeah, I think it would be. I mean,
Well, let me. So you teased it a moment ago about the big O for adjacency list and nested set model, and so what I want to say was that coincidentally, BigOCheatSheet.com was the tip of the week in that episode, and BigOCheatSheet.com has all of the operations for adjacency list already spelled out in Big O
Nice.
notation.
nice.
So normally when you talk about Big O notation, you usually use N, but these were not. So for example, storage for an adjacency list was the O of absolute V plus absolute E
What?
as an example. But then there were other ones that were kind of easy, like adding a vertex was O of 1, or adding an edge was O of 1, right? So you're not going to get much better than O of 1.
Nope.
Now, this is where my research became more difficult, was as it related to a nested set model. Like, what was it in terms of big O notation for a nested set model? And I couldn't find anything out there. But if you think about what a nested set model creates, and I'm open to feedback. But as I was thinking about it, what I came to in my mind that a nested set model actually ends up being is an NRE tree or a KRNE tree, depending on which one you prefer to call it. Right? It's not a binary tree, but it's an NRE or KRE tree.
Which is essentially the same as a binary tree, except it can have multiple nodes at each level.
Well, in a binary tree, okay, let's be clear. A binary tree, you have at most 2 nodes per any given one node.
Per parent, right.
And
Right.
the left is always lower and the right is always higher.
So in a NRE tree, there in 0, 1, and 2 are valid values, but it could also be 3, 4, 5, 6, whatever. There's no set number of how many nodes any one branch could have on it, right? And I couldn't find any place where in Big O notation where this was documented. What I did find, and this is also was already on the Big O cheat sheet, is that specific to binary search, the operations were more often than not for access, search, insertion, and deletion. Binary search in Big O notation is O of log of n, right? For the worst case scenarios for those same operations, it's O of n, right? So that's in terms of binary search. Now, both of those scenarios are not bad, right? They're
The worst case scenario is you do one for every.
yes, yeah. It's not O of 1, but at the same time, it's definitely not O of n squared either.
Right. But that's just storage.
But that's for a binary tree.
Right.
And if you have taken the time to do calculations to calculate what its O notation is, then maybe you have a better answer than me, because that was the best I could come up with, is that it's got to be somewhere close to that. I know it's not the same as binary,
Right.
but I feel like that's going down
Because it's more complex.
a good path, but it really depends on.
But that's the tough part too, though, because we're talking about SQL, right? It's not a programming challenge.
But these could be in-memory structures too. They don't have to necessarily be you could have your nested set model just as an in-memory structure, in your program, right? You could have you could represent your closure table or your path enumeration or your adjacency list or your binary search tree. You could represent all of these things as just in-memory objects.
Yeah, I don't know how it translates though. I mean, I get what you're saying. If you're going to do that programming wise, how you could actually do that search. But when you think about it, about how databases work, right, where they index things so that they know how to quickly find particular elements. With the nested set model, you're just saying, hey, where it's between this and this. And so I don't really know how to put that into. I don't know how it equates is what I'm trying to get at. That's a very fast operation in a database. And I don't know the complexity, because I'd have to dig way deeper than what I ever have to find out exactly how the database is storing that information and how it would equate to doing it in memory in something like C# or Java or whatever. So I don't know. Nested sets are stupid fast and they're highly efficient. I don't know what the Big O notation for it is.
Yeah, so I guess I'm putting the request out there that if anybody else has an answer as to the Big O notation for a nested set model, I would love to know that.
Yeah. So we were actually asked that question on episode 28. So if you go to www.codingblocks.net/episode 28, it's down there at the bottom of the page. If you know what it is, you can reply directly to him, because I don't think we have yet. So anyways, yeah, that was an interesting thing that came out of that particular episode.
Yep.
But anyways, that pretty much that wraps up that section of it. We've pretty much gone over in depth all the hierarchical data structures that maybe we're aware of.
Not all.
No,
There's a bunch, but they start to get weirder after this.
yeah, okay. So those are the primary ones that we've looked at.
Well,
Yeah, and all
there's
the
other
others are
like
based-
combinations where you combine a nested set model with an adjacency list, or whatever. There's some
Okay, yeah.
some permutations that you can get into.
Yeah. So now it is time for our tip of the
What? Tip of
weeks.
the week.
the weeks.
Tip of the week.
And I do love somebody
fail.
left us a review and actually called us out for that. That was awesome.
Oh yeah. Well, like you don't call us out every time.
Well,
We
got
try to get into this.
It's funny. We
Right.
need to change that. Anyways, all right.
I like it just the way it is. Tip of the week.
All right. So I'm going first this time. This is Joe. My tip, we actually got feedback on that too, saying our names more often. Tip of the week. So mine comes from Scott Hanselman again. He had a nice tip a couple days ago about using or setting up Chrome incognito mode as your browser default in Visual Studio. So when you hit debug, it pops up Chrome in incognito mode, which is going to, give you a new session. It's going to clear all your cookies, all that sort of stuff. So it's a nice way to get a fresh browser and a fresh session when you're debugging.
Well, that's really cool. Huh. All right.
You mean you don't use IE8?
right. All right. So my tip of the week, I don't remember what I was doing that required like large data sets, but I was.
That's always the best way to start a story.
That's the thing.
There I was.
Yeah. Right. I mean, I don't know. Anyways, I ended up coming across several resources for creating data sets. And one of them that I thought was really cool was Amazon.com has exposed some public large data sets. Things like NASA Next, there's the Human Genome Project, Common Crawl Corpus. So this corpus of web crawl data composed over 5 billion web pages. So these are all data sets that are freely available. So if you're trying to mock something up and you need some data to be able to test some things out with, this is a fairly cool little resource where you can go and get real data for free. So that's on aws.amazon.com
Sounds creepy.
public-data-sets. What's
Yeah.
creepy?
I said it sounds creepy.
It's
One
kinda
of them
cool.
is the U.S. Census data.
Yep, from 2000, right?
1980, 1990, and 2000.
Yep. So pretty cool stuff if you ever need some real fake data or some real data to play with for mocking some stuff up.
All right, and so here's a Git one for you, but I'm going to warn you to use this sparingly. I was kind of nervous about even talking about this one, but let's say you've done all your commits, and let's assume that you haven't already pushed anything. Nothing has been exposed out into the wild. You've done all your commits locally while you've been working on something, and now you're ready to bring in the latest version of some remote branch. Let's just assume it's master. And you're ready to package your unit of work up and send it on its way. Well, you can do a rebase and your pull all at one step, so that you can grab the latest from that remote branch, in this case master, and replay your commits on top of it to make, when you do your final push to the remote repository, it looks like just one simple little clean bubble of commits, rather than seeing your commits interspersed through other commits that other team members may have done. And the command is this: git pull -- rebase equal true, and then origin and master. So git space pull space -- rebase equal true space origin space master, and that'll do it.
That's actually really cool.
And
Yeah, if
and
everyone
then you
did
would
that.
do your push, and then that way, when all your team members see your commit that you made when you do your pull request, it'll just look as like one clean set of commits that have been built on top of it. Now I say, oh God, please use this sparingly, because if, for example,
Use it smartly.
okay, let's say that you are working in some branch and you have already pushed that branch to the origin, then you don't want to do this.
Right.
Okay? You only want to do this if your stuff has never seen the light of day anywhere else.
Because if you don't, then it's going to end up erasing things that were previously public. And so there'll be no...
Well, not necessarily racing. I wouldn't word it that way.
Okay.
What could happen is, let's say that Alan and I are working on a branch, and we're sharing that branch on some remote repository, and so we've already got a bunch of stuff in there, and Alan has based commits off of things that are already there. If I were to come back and do some rebasing on it, it would change his history of what he's been creating commits off of. But there's a bigger problem too, though, is that if you have already done this push in this example that we're talking about, you couldn't even, if I did this git pull rebase, git pull rebase true origin master command, and then tried to push something that has already been published, that push is going to fail, because it's going to tell me I have to do a pull first in order to make it match, because there's already been history that's been pushed remotely.
Interesting.
So that's why I say, like, you definitely want to use it sparingly, and only when history has not already been published externally.
Yeah. Oh, and one thing that's important to know is when you rebase, it doesn't squash all your commits into one. So any commit messages you make that might be somewhat,
You better mean them.
yeah, might be a little offensive, or like, I can't believe this.
Are you telling me that you used whatthecommit.com to get your best commit messages?
I might have gone one up on that. So, but yeah, just know that all your commit messages will still be there, even if you thought they were just going to be your local copy.
Let's see. The random commit for the evening is it's secret.
Nice.
So, yep, that's I think we've hit it all, right?
That's a good tip. Yeah, that was our tips of the week. So wrap it up with a little summary. We hope you've enjoyed the last two shows about different ways of storing hierarchical data. Last episode 28, we talked about adjacency lists and nested sets. Just to do a real quick recap on those, adjacency lists was when your node stored the parent ID, which was simple but scaled poorly. Nested sets, we were just talking about that, but each node keeps track of its place in a hierarchical tree, and it's fast to query, harder to maintain. The two we talked about this time, path enumeration, you basically store the breadcrumbs in simple text and you parse it out, which is pretty gross. And then there's closure tables, which is similar, but with data integrity, and can potentially, but maybe not, end up in lots of extra rows.
Yeah, so with that, subscribe to us on iTunes, Stitcher, or more using your favorite podcast app. Be sure to leave us a review as well on those platforms. Tell a friend or three. Make sure, spread the word. We really do appreciate that.
Yep, and contact us with a question or a topic. Leave your name and however you'd like to be mentioned on the show. And visit us at codingblocks.net, where you can find our show notes, examples, discussions, and more.
Yeah, and send your feedback, questions, and rants to comments@codingblocks.net, and make sure to follow us on Twitter @codingblocks.
And that is it. We'll be back soon with another episode.
Soonish.
To celebrate their launch of version 6 of Independ, they are offering a 20% off discount through the end of July 2nd. I know that's only a few days away, but if you head over to www.independ.com and you enter in the offer code INDEPENDV6 coding blocks, all one word, then you can get 20% off their latest version of their static analysis tool.